Hello there, my name's Glenn Berry and I'm a principal consultant with Dr. DMV LLC. This is going to be Hardware 301, Choosing Database Hardware for SQL Server 2019. This is a little bit more about me with my email and my Twitter handle and also my YouTube channel. I know how to brew beer. I'm an all-grain brewer. I've been brewing beer for about 4 years, so it's kind of a fun hobby that I have that has nothing to do with SQL Server, to be honest, but it's just a lot of fun. So what we're going to talk about in this presentation is the importance of database hardware for SQL Server and some things you should think about for hardware selection criteria when you're getting ready to spec out a new server. We'll talk about Intel versus AMD processors and the difference between capacity and performance, and then some nitty-gritty details about processor selection, which is very important for SQL Server for licensing reasons and performance and scalability. So the importance of database hardware, if you've ever been in production DBA, you know that your database servers are mission critical assets, and if things are going wrong with them and they're performing poorly, people tend to notice that pretty quickly. And the problems that you see are going to be very noticeable, and if you have bad hardware that somebody did a bad job of choosing, you're going to be stuck living with it for a long time. And if you made a bad hardware choice, you might be paying a lot more for your SQL Server licenses than you actually needed to. So modern server hardware is actually very affordable, and old hardware is bad. So you've got some old server hardware from 2, 3, 4 years ago. Don't feel the need or don't be pressured to reuse that old hardware when a new version of SQL Server is released. That's false economy. You quite often are going to spend a lot more money on licenses than you needed to, and you're going to give up a lot of performance in many cases. And SQL Server tends to be very hardware intensive. So economizing on your hardware as if your database server was a web server is usually a very bad idea, because the cost of your SQL Server core licenses, you want to make sure you get the most performance you can out of each one of those licenses that you have to purchase. Good hardware is not a panacea. I want to make sure I get that point across. If you've got a very bad workload with very poorly designed queries and poorly designed applications, you can easily overwhelm the very best hardware and storage. There's no doubt about that. But having fast hardware and storage gives you a lot more headroom for accidents, and it just gives you better performance. And the details of your hardware and storage actually do matter. Don't let somebody tell you that the hardware is not important. So you want to think about your workload. What kind of workload is it? Is it an OLTP workload? Is it more of a data warehouse reporting type of workload? Or is it a mixed workload? Because what kind of workload you're dealing with is going to affect your hardware and storage choices. And you also need to think about, is it going to be a bare metal installation or is it going to be virtualized? Because if you're going to be using virtualization, you want to try to avoid the common tendency to just use a general purpose high core count server that has lots and lots of guests on there and a low clock speed on the processor, because that's not going to be good for SQL Server. You're going to have poor performance and have to use probably more core licenses than you actually need to support your workload. So one thing you really need to think about as you're looking at hardware is your SQL Server 2019 license costs. And it makes a big difference whether you're on Standard Edition or Enterprise Edition. Now with Standard Edition, you can actually have a server license and then have client access licenses for each user or device that accesses the server. And if you're a small organization and you can actually count the users and devices, that might be a lot less expensive. But most organizations don't have that luxury, so you're usually going to be using core licensing for both Standard Edition, and then you have no choice, you have to use it for Enterprise Edition. And you can see in that table how much those core licenses cost. And you have to buy a minimum of 4 core licenses per physical processor and a minimum of 4 core licenses per virtual machine. And that can be a problem. And you can see that Enterprise Edition is roughly 4 times more expensive than Standard Edition. So paying attention to how many licenses you have in the system is really important, because the licensing costs are going to easily outstrip the hardware costs, often by an order of magnitude. So here's the SQL Server 2019 license limits. With Enterprise Edition, you can use whatever the operating system supports for memory and also for sockets and total number of cores. So whatever the OS supports, you can use it in SQL Server. And currently the limit is 24 terabytes with Windows Server 2019. With different Linux distributions, it sometimes is lower, but it's a very high amount. And most of the hardware you're going to be able to buy won't even approach that, to be honest. But where you have a problem is Standard Edition. Standard Edition is still limited to 128 gigabytes per instance, plus a little bit more for column store and in-memory OLTP, and that's for the database engine. So you don't want to go out and get a server with 2 terabytes of RAM if you know you're going to be running Standard Edition, unless you're willing to have multiple instances installed on that server. And where this catches more people is the socket and core count limits. So you're limited to the lesser of 4 sockets or 24 cores, whichever is lower for Standard Edition. And if it's a bare metal machine, you're counting physical cores. And if it's a VM, you're counting virtual cores or logical cores. And that's no change, those limits from SQL Server 2017. And so the core count limit is what trips up a lot of people, because modern server processors have much higher core counts than that, even for a single processor. And if you're looking at a dual socket or even a 4-socket server, you can far, far exceed that limit without even really trying. So it's something you need to be aware of. Now, choosing between Intel and AMD, you need to think about a few things there. So you've got performance differences and cost differences and security differences. Now, Intel, with their latest and greatest server processors, still has a small advantage in single-threaded performance, although the gap is really closed. AMD has an advantage in multi-threaded performance. They also have a higher memory density and higher PCIe capacity. And the cost point of view, Intel processors are quite a bit more expensive than AMD processors, although Intel has taken some price cuts in January and February of this year, so the cost difference is not quite as bad as it used to be. And then on the security front, Intel unfortunately just has a lot more known security exploits, and a lot of that's because Intel has much more of a market share and they're a bigger target. But they are still vulnerable to a lot more exploits that we know about than AMD is. Now, Intel performance advantages, they have higher clock speeds that help their single-threaded performance. They also support some specialized instructions that are more oriented towards artificial intelligence, and they don't really help SQL Server. Now, they also support Optane persistent memory if you've got a new enough Intel processor. Now, if you use that, it's going to slow your regular DRAM down to 2666 rather than whatever speed it might be running at. And then finally, Intel CPUs are better suited for OLTP workloads because of their better single-threaded performance, but the margin is pretty small now, and you'll see that later on in this deck. In the current Intel server processor families, you've got the Xeon E family, which is for single socket servers that go up to 128 gigs of RAM and 8 cores. And that's the Xeon E2200 series that came out in the second quarter of 2019. It's 14 nanometer Coffee Lake. But what most people are going to probably be looking at is the second generation Xeon Scalable family, which is Cascade Lake SP. And that came out in 2019 also. And it's divided into bronze, silver, 2 different golds, and then a platinum family. And for SQL Server use, you should never, ever use the bronze or silver family processors. Those are more for web servers or file servers. And remember, Microsoft doesn't care what kind of processor it is. All they do is count cores. So if you have an 8-core processor that's really slow because it's a bronze or a silver, you're just wasting your money. If you got a gold that had the same 8 cores but a much higher clock speed, you're much better off for SQL Server. And then you also have the 3rd generation Xeon Scalable family called Cooper Lake. And that was just released in the second quarter of 2020. And unfortunately, that's not good for SQL Server. It's for 4-socket and 8-socket servers primarily, and it has low clock speeds, and it's more aimed at the machine learning and AI market. It's got some new instructions and features that support that. So do not get Cooper Lake for SQL Server. So you're going to be looking at gold or Platinum processors from Cascade Lake SP. So Nehalem was the first generation that Intel supported NUMA instead of SMP. And if you look at this table, you see the darker bands and then the lighter bands. And the darker bands are what used to be called TOC releases, and the lighter bands were TIC releases. And a TOC was a new architecture, and then the TIC was the same basic architecture that went down to a smaller manufacturing node. And this was pretty reliable for quite a long time. It was called tick-tock, tick-tock. But what's happened is Intel has been stuck on 14 nanometer since 2016. And that's causing them more and more problems that we'll talk more about later. But you can look at this chart and see how old your existing processors are. And then you can also see what's coming out in the future. And this is what we know about as of now. The next release from Intel is going to be called Ice Lake for servers. And that's probably coming out sometime during the first half of 2021. So there's been a delay and that schedule's been pushed out from what it used to be. So if we compare some Intel versus AMD TPCE results, and TPCE, by the way, is an OLTP benchmark that runs on SQL Server. And so on the left, you've got a 2-socket Lenovo system running Intel Xeon Platinum 8280s. And then on the right is a 1-socket Lenovo system running an AMD EPYC 7742. And you can see here that the score for the Intel system is a little bit higher. The 7012 score, that's the total system throughput. That's the bottom line score. And it's only on 56 cores. And then if you divide that total score by 56, you get 125.22 score per core. And so that's a measure of the single-threaded performance of that system on this benchmark. And this is an actual TPCE benchmark result. And then on the right, you can see the AMD system. This is another actual score, is a little bit lower, even though they have more cores. And the score per core is somewhat lower. It's roughly 20% lower. So there's still a gap, although I'll point out that this is for the top of the line, highest core count processors from each company. If you go further down the stack on the lower core count, the gap is much, much lower because AMD has some new frequency optimized SKUs that I'll talk about just in a little bit here. So moving on, AMD has some performance advantages. They've got higher IPC, instructions per clock, and they've got a more modern architecture with much larger L3 caches and higher memory speed and 8 memory channels instead of 6 memory channels per socket. And they also have a huge advantage for storage bandwidth. They're using PCIe Gen 4 instead of Gen 3, and they have more lanes per socket compared to Intel. And then all this together makes AMD CPUs much better for data warehouse and reporting workloads. And they're also very well suited for general purpose virtualization hosts. So here's the AMD server processor family tree. And this goes back to 2010. And back then, AMD was using the first generation of their Opteron processors. And frankly, those were terrible for SQL Server. They had extremely poor single-threaded performance, and they also had very high core counts. And not too long after this is when SQL Server 2012 came out that switched from processor licensing to core-based licensing. So that made it even worse for AMD. And so AMD processors were just garbage for SQL Server all through the Opteron family. But then when the EPYC came out in 2017 using the first generation Zen architecture, they made a huge leap in single-thread performance. But they still were pretty far behind Intel. But then when the Zen 2 Rome came out in 2019, they really closed that gap. And what's coming next is the Zen 3 Milan later this year. And that's probably going to pass Cascade Lake. It's very likely that Zen 3 will have better single-threaded performance than Cascade Lake. And Intel's still going to be stuck on Cascade Lake until Ice Lake comes out. So there's going to be a gap there. All right, so here's an actual TPCH result comparison. And TPCH is a data warehouse benchmark. And you can see on the left, it's a 2-socket HPE system running Intel processors. And on the right is a 1-socket AMD system from HPE. And to be fair, this is a Platinum 8180, so it's one generation behind. It's a Skylake instead of Cascade Lake. But there was not much of a difference when you went to Cascade Lake. So anyways, getting back to the results here, The number, the 1,009,000 number for this scale factor size data warehouse is actually higher for Intel, but they have 56 cores in this system. And if you look at the AMD system, it's only have 32 cores. And it's the same size data warehouse, so it's valid to compare them. So even though the top line number is lower for AMD, they have only 32 cores, so they're doing much better if you look at that top line score divided by the number of cores. So this is some proof from an actual officially submitted benchmark that AMD is doing better for this sort of a workload. So this is some more comparison points between the current top of the line or newest AMD EPYCs versus Cascade Lake SP. So you can see that EPYC has more cores, they've got more PCIe lanes, they're on a newer PCIe generation, and they have faster memory, and they have a higher memory capacity per socket, but to be honest, this is not really that valid because you're practically limited by what the motherboard will support and the size of your DIMMs that you can actually buy. But if you got past that, you're not limited by what the CPU is doing. And Intel can go above 1 terabyte, but you have to pay extra for it with an L SKU, and they charge you about $3,000 extra to have higher memory support. So keep that in mind. And then one thing here is that AMD does not support Optane DC persistent memory, and Intel does. So if you're interested in that, then you're going to need to go with Intel. All right, so here's some scary logos. You've got Meltdown, Spectra, Foreshadow, and Zombie Load. Maybe you've heard of some of these. And these are security exploits that have come out, that target processors. And so there's more details here. And most of these, unfortunately, are Intel-only vulnerabilities. A few of them affect AMD, but usually in more of a limited fashion. And again, part of this is probably because Intel has much larger market share than AMD, and they're just a bigger target for the bad guys. But because of this, when all these things come out, there have to be software fixes and firmware updates. And quite often, these fixes affect performance. So if you're concerned about this sort of stuff and you apply all the patches, you're going to take more of a performance hit, unfortunately, on the Intel side to fix all this stuff than you do on the AMD side. So that's something else to think about. And depending on where you work, this could be a big deal, or maybe you don't care about it too much at all. Now, there's more information here. Microsoft has some very specific guidance for SQL Server regarding this sort of stuff, and they recommend you be on certain levels of versions of SQL Server and certain cumulative updates to have security fixes to try to fix this. And then on the server side with the OS, Microsoft's got guidance for Windows Server. So AMD has some guidance here also, and Intel has guidance for their specific processors. And then I've got a couple articles about comparing Intel versus AMD processor security and some more information about Zombie Load there. All right, something else I want to talk about is the difference between server capacity and server performance. And there's several different ways of looking at server capacity. CPU capacity is the multi-threaded performance of all the CPU cores in the system. And memory capacity is the max memory amount that you can support and how much throughput you can get from that memory. And that's really important in certain things such as data warehouse scenarios. And then I/O capacity is the number and generation of PCIe lanes and the total number of IOPS that you can support from that. So those are different ways of looking at the capacity of the server. So another way of looking at it is how many concurrent queries can you support? How many users can you have on there hammering away at the server? How much memory throughput can it support? And then how much sequential I/O throughput can your server support? Think of your capacity of the server as a Peterbilt truck. How many tons can that truck handle? So then server performance, there's several different ways of looking at that. So your CPU performance is the single-threaded performance of one CPU core. How fast is it? And then memory performance is your memory speed and latency. And your I/O performance is your I/O latency and I/O bandwidth. Another way of looking at performance is how fast is a single-threaded query. A lot of OLTP queries just run on a single thread, and how long does it actually take for that query to execute? And that's quite often controlled by the single-threaded performance of the processor, assuming you don't have any storage or memory bottlenecks. And then how fast can you read and write from the buffer pool? and how fast can you read and write from your storage. So those sorts of things are performance rather than capacity. So that's more like a Tesla Model 3 performance. All right, so moving on, how do you actually compare processors? Well, one method is to use actual TPCE benchmark scores. And so what you do is you find the best actual score for a particular processor family like Cascade Lake SP. And that's what I call the flagship score. Because the manufacturers like HPE and Lenovo, all they ever do is submit a flagship score for the highest core count processor so that their bottom line score for the benchmark is as high as possible. And the problem with that, from our point of view, is that you may not want to buy that particular processor because it's going to cost a lot of money to license it for SQL Server. If you want to compare that actual score to another processor in that same exact processor family, here's how you do it. So you adjust the actual score for the core count and base clock speed difference between the two processors. And once you've done that, you're going to have an estimated TPCE score and then a score per core. And the total score is a measure of the CPU capacity of the system. And then the score per core is the single thread performance of that processor. And having these numbers is very, very useful for sizing calculations, for upgrades and consolidation and virtualization. And this works really well. I mean, it's not 100% accurate, but it's much better than just picking a number out of the air. So here's an example of what I'm talking about. If you want to compare two processors from the same generation, which is really important, by the way, the same family and generation. So you're going to compare, in this example, an Intel Xeon Platinum 8280 that has 28 cores and a base clock speed of 2.7 gigahertz. And the official score for a system using that in a two-socket system is 7,012.53. So that's the capacity of that system. And if you divide that by 28 cores, or actually 56 cores, I should say, because there's two sockets, you're going to get a score per core of 125.22. So that's a measure of the single threaded performance of the Xeon Platinum 8280. So now we want to compare that to a Xeon Gold 6250. And that processor only has 8 cores, but it's got a base clock speed of 3.9 gigahertz, much, much higher. So if you go through and do the math, your estimated score for that Xeon Gold 6250 is 2893.02, and the score per core is 180.81. You can see that the single thread performance of that Xeon Gold 6250 is a lot higher than the Platinum 8280. Down on the second half of this slide is actually walking through the math. So the core count adjustment is 8 divided by 28, and then the base clock speed adjustment is 3.9 gigahertz divided by 2.7 gigahertz. And then you take those two numbers and just multiply it through against the original score of the actual benchmark, and then you get the estimated score. So hopefully that is pretty clear how you do that. It's just basic arithmetic. This is a really important slide here. This is showing I went through and did this math for the best processors in each core count from Cascade Lake, and you'll see the same thing for AMD EPYC. What you have here is, this is a 2-socket system, by the way. So at the top, you've got a Xeon Gold 6258R, and where it says total cores equals 56, that's the total cores in the entire system for 2 sockets. So it's actually a 28-core processor. You can see the actual TPCE score in that column, and then you jump down to the other processors, and the core counts are going lower. So you go from a 28-core to a 26-core processor, and then a 24-core processor, and so on. And at the very bottom, the Xeon Gold 5222, that only has 4 cores, but remember, we're doubling because it's a 2-socket system. And what you can see here is that TPCE score column shows you the capacity of the system with these different processors. So that's, again, a measure of how much workload can this system handle. And that's the main point of this TPCE benchmark. But then if we take that score and divide it by the number of physical cores in the system, that's where you get the score per core count. And you can see here that the ones on the bottom rows have higher scores per cores because they have higher base clock speeds. And with a server processor that's under any kind of a load, it's going to be running its base clock speed most of the time, not its turbo clock speed. So that's why we use that for these measurements. If you look closely at this chart, you can see a few interesting things. So for example, the Xeon Gold 6248R has a TPCE score of 6678.60. And that's actually higher than the Xeon Platinum 8270 just above it, even though that has more cores as the 8270 does. What this tells me is you would be dumb to get the 8270 because you're going to have less capacity and lower single-threaded performance. And more importantly, on the far right, that license cost column, what that means is how much would it cost to buy SQL Server Enterprise Edition for this server? You're going to be saving nearly $30,000 by picking the Gold 6248R instead of the Platinum 8270. You're going to have more capacity and better single-threaded performance. So that's kind of a no-brainer. Save enough money to pretty much buy the server and still have more capacity and more performance. So this is a very important chart, and I suggest that you take a screenshot of it or use it for reference, because these are the best choices at each core count. All right, so here's the same thing for AMD EPYC Rome. The ones in green are those frequency optimized SKUs that I mentioned earlier. Those are the ones that you want to pick if at all possible. They have much higher single-threaded performance because they have higher base clock speeds. And so you can see here that the ones in green, those frequency optimized SKUs that have a naming scheme like 7F and a couple of numbers, those are the ones you want to pick. And their numbers for score per core are very close to Intel. They're still not quite as fast, but it's a very tiny gap. All right, so here's a final example here of a very bad CPU choice versus a very good CPU choice. If you're going to go out and get a new 2-socket server, and it's a Dell R740, and you could pick 2 Intel Xeon Silver 4208. Remember, I told you silver is bad. Don't ever pick silver. But let's say that your server admin does this without talking to you. So he gets the Intel Xeon Silver 4208. What you could have picked instead is the Intel Xeon Gold 5222. And that's a much lower core count processor. It actually runs a lot faster. If you made these two choices, the Xeon Silver 4208 has slightly higher capacity. The TPC score is a little bit higher, but your license costs are doubled, and your single-threaded performance is only about 60% of the Xeon Gold. So you're going to be wasting $54,000 and have much, much lower performance that your users are going to notice. And so this is an extreme example. And the reason your server admin might have done this is that Silver processor is a lot less expensive. It's only $417 each. But you're only going to save $1,600 by picking that cheaper processor, but you're going to spend $54,000 more on the licensing. So don't make this kind of a mistake. Here's some recent articles that I've written about this subject that you might want to take a look at. And then here's some more hardware references, just background information about server hardware. And I want to really give a shout out to Serve the Home. They're a really good website that focuses on server hardware and analysis of different processors and making smart choices here. So I want to thank you for listening to this. And if you've got any questions, feel free to comment in this, and also send me an email or reach out to me on Twitter. I'm very active there. And I just want to thank you for listening to this.